Have you ever looked up at the sun and wondered how it burns so brightly? It's a question that has intrigued humanity for millennia. The sun, our closest star, is a massive ball of hot gases, primarily hydrogen and helium. But what makes it shine so brilliantly? We know fire needs oxygen to burn. On Earth, a campfire or a candle flame requires oxygen from the air to sustain itself. Yet, there's no oxygen in space. The vacuum of space is devoid of the elements that typically support combustion. So, how does the sun keep burning for billions of years? The answer lies in nuclear fusion, a process that occurs in the sun's core. The sun's ability to produce light and heat has fascinated scientists for centuries. Through careful observation and study, they discovered that the sun's energy comes from the fusion of hydrogen atoms into helium. It's a question that leads us on a fascinating journey into the heart of our solar system and the fundamental laws of the universe. Understanding the sun's inner workings helps us grasp the very nature of stars and the forces that govern them. First, we need to understand that the sun doesn't burn in the way we typically think of fire. Fire, like a campfire, needs oxygen to exist. When wood burns, it combines with oxygen, releasing heat and light. This process is called combustion. However, the sun's energy production is entirely different. It doesn't rely on oxygen or any kind of burning in the traditional sense. Instead, the sun is powered by a process called nuclear fusion. Nuclear fusion is the process that powers the sun. This incredible reaction is the very heart of our star, providing the energy that sustains life on Earth and drives the climate and weather systems. It's a reaction where two or more atomic nuclei combine to form one or more different atomic nuclei and subatomic particles, neutrons or protons. In the sun's core, hydrogen nuclei fuse to form helium, releasing vast amounts of energy in the process. The difference in mass between the reactants and products manifests as either the release or absorption of energy. This mass-to-energy conversion is described by Einstein's famous equation, E=mc², highlighting the immense energy potential of nuclear fusion. Nuclear fusion is a powerful process, releasing enormous amounts of energy, much greater than what's released in chemical reactions like combustion. While combustion powers engines and fires, fusion powers stars, making it a far more potent source of energy. This is why the sun can shine so brightly and produce so much heat. The energy from fusion travels from the sun's core to its surface, radiating out into space and reaching Earth, where it supports all forms of life and drives our planet's natural processes. Section 4. A star is born. Inside the sun's core. Deep inside the sun's core, the temperature reaches a staggering 27 million degrees Fahrenheit. This is an environment so extreme that it defies our everyday understanding of heat and pressure. This intense heat and pressure create the perfect environment for nuclear fusion to occur. Nuclear fusion is the process that powers the sun, providing the energy that lights up our solar system. Think of the sun's core as a giant cosmic pressure cooker. The immense gravitational forces compress the core to such an extent that it becomes a furnace of unimaginable power. Here, hydrogen atoms, the simplest and most abundant element in the universe, are constantly bumping into each other. These collisions happen at incredible speeds due to the extreme conditions. Under these extreme conditions, they overcome their natural repulsion and fuse. This fusion process releases a tremendous amount of energy, which then radiates out from the core and eventually reaches us as sunlight. The energy produced in the core takes thousands of years to travel from the core to the surface of the sun, and then just 8 minutes to reach Earth, providing the light and warmth essential for life. Section 5. From hydrogen to helium. The fusion reaction. When two hydrogen atoms collide with enough force, they combine to form a new element, helium. This process releases a tremendous amount of energy in the form of light and heat. This energy then radiates outward from the sun's core, eventually reaching Earth as sunlight. It's the same energy that warms our planet, drives our weather patterns and allows life to flourish. Section 6. Beyond the flames. Combustion versus fusion. It's important to remember that combustion and nuclear fusion are entirely different processes. Combustion is a chemical reaction that requires oxygen and releases a relatively small amount of energy. Nuclear fusion, on the other hand, occurs at the atomic level, doesn't need oxygen, and releases an immense amount of energy. This difference in energy output is what makes the sun such a powerful and long-lasting source of energy. Before we wrap up, let's take a moment to appreciate the sun's incredible impact on our planet. The sun is not just a distant star, it's the life-giving force that makes Earth habitable. From the warmth that sustains life to the light that drives photosynthesis, the sun's energy is at the core of our existence. Consider the cycles of day and night, the changing seasons, and the weather patterns. All of these are influenced by the sun's energy. Without it, our world would be a frozen, lifeless rock drifting through space. The sun also plays a crucial role in renewable energy sources like solar power, which harnesses its abundant energy to generate electricity. This clean energy source helps us reduce our dependence on fossil fuels and combat climate change. So next time you feel the warmth of the sun on your skin, remember the complex and fascinating processes happening millions of miles away that make life on Earth possible. Thank you for watching. If you enjoyed this video, please like, share, and subscribe to our channel for more amazing content. See you next time.